Hello everyone. In this video I'm just going to give you a quick introduction to standard deviation and normal distribution. I'm going to use one example and hopefully you'll be able to apply this going forward. So let's start with standard deviation and let's try to develop some understanding of what it is, right? Let's use this example. Let's say we take the maths exam results of 20 random people in a random class somewhere. I've just made these numbers up. And let's say their percentages are as follows. Now, before we proceed, let's just take a second to have a look at these percentages and make some general comments on the data. You can pause the video, have a quick think. Okay, so we can see that there's obviously some very high achievements in the 90s, but there's also some very, very low achievements. And there's also a lot in the middle, so it's actually all over the place. We've got high achievers, low achievers, and people in the middle. You know, we got 30s as well, we got 70s as well, so above and below average, if you like. So it's really a big spread of percentages. Now, let's say we want to analyze the data, find out more information about it, all right? And well, if we're talking about standard deviation, we actually need the mean. So that's the first thing we're going to do. We're going to calculate the mean, and we're just going to use a calculator. So quick refresher on how to use your GDC to find the mean. So all I've done is I've opened a new stats page, put all my scores in column A, called it scores, and then go into menu, statistics, stat calculations, your one variable statistics. This table should pop up. Just adjust your columns wherever your data is, where you want your results to be output. And leave your frequency as 1 because there's no frequency in this list of data. There's just 20 data points, that's it. So, and then press OK. Find the mean, which is X bar, and then you'll get 54.3. So the mean of these 20 scores, I must have just bumped my keyboard there, is 54.3% approximately. So imagine now that you have this value and no more information, okay? If you just had the mean, how much of a story does this number actually tell you about the data set? So let's say that the lowest score is 0 and the highest score is 100%. If you were only told that the mean is 54.3, then you can probably draw conclusions like on average, if 50% is a pass, it is a pass. It's not a very high pass, but it's there. But you really can't say anything more, right? So what would be more useful? All right, this is where we're going to introduce the standard deviation. What would be more useful if how we knew the data was spread out, right? So we need some sort of statistical measure that gives us more of a indication of how spread out the data is. So that's what the standard deviation is. It's a measure, it's a number, but it's a measure of spread. It tells you how far each piece of data is from the mean on average, right? So knowing this, all right, let's predict. Let's predict what the standard deviation is going to be like for these 20 scores, right? So we already said that they're very spread apart. Okay, we got low scores, high scores, scores in the mid-range. Okay, so if the data is spread apart, then you can expect your standard deviation to be quite high. Okay, compared to the mean, right? Compared to the mean. So how do we calculate the standard deviation? Very easy. It's on the same page as the stats you just calculated. All right, you want to find sigma. So this Greek letter here. I'm not going to go into S versus sigma, but just know that pretty much all the time we're going to be dealing with sigma. All right, so the standard deviation in this case for this set of data has a value of 26.6. So how do we interpret that? Well, on average, very simply, on average, each student's score is approximately 26.6% away from the mean. So let's have a think about that. The mean is 54.3. So if each student's score is on average 26.6% away, well, that's actually quite large, okay? That means you pick a random person, they could be anywhere. Well, you can't really say that they're going to be around 54.3% because the standard deviation is so high. All right. So what conclusions can you draw from the data set? Now that you have standard deviation, it does tell you a bit more of a story. Okay, you can draw the conclusion that the data is quite spread out. It's very inconsistent. If we're talking about math scores here, the class, for example, the performance is very inconsistent. You got really low scores, you got really high scores. Okay, so hopefully that gives you an idea of what the standard deviation is. Let's now use the standard deviation to learn about something called the normal distribution. And again, I'm just going to introduce you. Okay, we're not going to do anything overly sophisticated. All right, so what is it? You can think of it as a graph that represents your data set, okay? But I'm going to slow down. We need to make some assumptions, okay? So for something to be normally distributed, we need a large sample of data. Okay, so we're gonna assume that instead of 20 students, all right, let's imagine that we now took the mass exam scores for 20,000 students, all right, wherever that is. And let's assume that both the mean and standard deviation just happen to be the same as these numbers we've just had. All right, so for 20,000 people, we're going to imagine the mean is still 54.3% and the standard deviation is still 26.6%. Okay, so we need a large sample of data because it just so happens that for most quantities that we're trying to measure, let's say we're trying to measure height of people, we have a whole bunch of people, we're trying to make a graph showing how tall they all are. Okay, the graph of the data most of the time will be bell-shaped or approximately bell-shaped, and that means this. All right, symmetrical. We call this a normal distribution. Okay, it is symmetrical about the mean. So let's have a quick look at how do we interpret this. Well, let's say now this is our graph for exam scores. So my exam percentage is going to be on, I'll talk about this real soon, on the horizontal axis. The vertical axis represents the frequency, or in this case, it's our number of students, right? So just imagine that we have a huge number of students. Now, we can expect that a large number of those students would achieve a score very close to the mean. And as we go further and further away from the mean, in either direction, there's going to be less and less students achieving those scores. Okay, so you can think of this, let's say, we're trying to model the heights of a large group of people. You can, we know logically that most people will have or be close to the average height, right? And as we go further and further away from the average height, there's going to be less and less people. Okay, and then we can relate the proportion of people as the area under this graph, or as a percentage. Okay, so what do all these symbols mean? Right, so we just said that the peak, okay, the midpoint of the graph, if you like, okay, is the mean. So in this case, our mean is 54.3, right? And then we can So how we use the standard deviation here, we go, one standard deviation away from the mean, two standard deviations away from the mean, and usually we don't really go beyond that, because what generally happens is that if you have anything that's normally distributed, approximately 68% of the data will always be within one standard deviation of the mean. Okay, and we're going to do an example very soon to try to understand this a bit more. Now, if we go two standard deviations away from the mean, all right, that's going to encapsulate around 95% of our data, which is a lot, right? And then if we go even further, that basically captures all our data, right? So we don't even tend to go beyond two standard deviations all the time. So remember that standard deviation represents spread, and this is one of the ways we can use that, all right, in a normal distribution. So what you need to remember is, well, these values, and if one standard if 68% is within one standard deviation and the graph is symmetrical, then we can say that approximately 34% is each section here, right? And then you can do this for the other percentages as well. So let's put this into a bit more context, okay? So let me rub this out and let me just talk through it again. So what sort of questions will you have to answer? Well, things like this, right? So let's say you ask approximately what percentage of students scored above 27.7%. Okay, so why is this number so specific? Well, there's a reason for that. I did that on purpose. So remember, our mean is, we're still talking about exam scores here. Our mean is 54.3 and our standard deviation is 26.6. We need to try to get 27.7 out of that. Is there some sort of relationship? So if we do the mean, well, we can see that this number is below the mean. And let's see how many standard deviations below the mean gives us 27.7. So let's try, well, it's not going to be more than one. So if we do mean, take one standard deviation, so sigma, that's going to give us 54.3 minus 26.6%. And that actually equals 27.7%. All right, so this number represents one standard deviation below the mean. And below mean. So on the graph, you really need to use the graph for any sort of normal distribution question. That represents this value. All right. Now the question is approximately what percentage of students scored above this. Well, that means we want the area all the way through here, right? I should, instead of doing that, maybe I just do that, okay? We want this whole area as a percentage. Now, using these numbers, okay, I can calculate that area. So we already said before that this section was 34%, and since the graph is symmetrical, from the mean onwards, the upper half of the graph, that's going to be 50% of our data. So approximately, because these are all approximates here, we can't say for sure. All right, 34% plus 50%, which is, I'll write it here, approximately 84% of students scored above 27.7%. Okay, so that's an example of how, or what the normal distribution is, how we use it. Just remember that if you have a large amount of samples for any quantity, really, it will look and behave like this. Or I just used exam scores as an example. You could get all sorts of real-life scenarios. All right, so a quick introduction about standard deviation and normal distribution. I hope that helped your understanding on these concepts. See you next time.